Hello everyone, welcome to Electronically Connected. In this video, we will be covering yet another combination logic block which is called a decoder. We will be covering different configurations of a decoder, that is a 2:4 decoder, a 3:8 decoder and a 4:16 decoder. We'll also be covering how to make a bigger decoder using a smaller decoder. So let's get started. A decoder is another type of our combination logic blocks that we have seen in our previous videos, like the mux or a demux. What a decoder does is it takes in a code and it turns it into a set of signals. A decoder is generally used to decode a particular signal that is given to it into its respective signals. It works in a really opposite fashion of how an encoder works. We will cover what an encoder is in the next videos. So, a decoder has the same number of inputs and output patterns that we have seen previously in our muxes and demuxes. So, it has n number of inputs and 2 raised to n number of outputs. So, for example, if we have 2 inputs, if our n is equal to 2, then 2 raised to 2 is equal to 4. That means we'll have 4 number of outputs. So, that means this is a combination of 2:4 decoder. Similarly, if our n is equal to 3, so this is my number of inputs, so 2 to the power 3 is 8. Now this will give a combination of 3:8 decoder. The outputs that we get in this decoder are in the form of minterms. We have covered what minterms are previously. Please refer to the videos in my page to understand what is a minterm. So just to recap, a minterm is a combination of elements in a dot form. So we have A, B, C, and this is a form of minterm. So now let's see what is a 2:4 decoder. So let's start with a 2:4 decoder. We know 2 is my number of inputs and 4 is my number of outputs. So let's draw a block with 2 inputs. Let's call it A0 and A1, and we have 4 outputs. This is Y1, Y0, Y1, Y2 and Y3. This is my 2:4 decoder. Now a new thing that we have in a decoder is that we have something called an enabler. So we have an enable input. Now let us see first understand what is the truth table behind the decoder. So we have our enable E, our inputs A1, A0 and output Y3, Y2, Y1 and Y0. Now what is the function of my enable bit over here? Unless and until my enable bit is not 1, we do not care what the input is. My output will always be 0. So basically we can see that enable has the power of enabling this whole block. As in when my enable becomes 1, then my input values start. So we can have 4 combinations because we have 2 inputs. In all of these cases, my enable is 1. Now, for the very first combination of input 0, 0, we have only 1 over here. Now, in the next case, we have 0, 1 and Y1 is 1. At 1, 0, Y2 is 1. At 1, 1, Y3 is 1. And the rest of the outputs are 0. So there we have it. So basically we can see that this is decoding my inputs. So if my input is 1, 1, the output we get is 1, 0, 0, 0. So it basically decodes 1, 1 to 1, 0, 0, 0. Now let us see its equations. So let's first see what is Y3. Y3 is formed by the combination of enable is equal to 1, A1 is equal to 1 and A0 is equal to 1. So E dot A1 A0. Remember we are min terms. A decoder follows min terms. Now Y2 is a combination of 1, 0. Again enable is 1 and Ebar 0. Y1 again enable is 1. A1 is 0. So A1 bar dot with A0. And Y0 again its enable is 1 with both of my inputs as 0. So we have them as bar. And here we have it. These are our 4 equations that is used for deriving my output. So we can see that we have 4 equations. That means we have 4 AND gates, and we have 2 inputs can get NOTed. So we have 2 NOT gates, and there we have it. Let's try and make an equivalent circuit of our equations. So we have 4 AND gates at the end. So let's draw the 4 AND gate first. 1, 2, 3 and 4. Each of these are for my separate outputs. So Y3, Y2, Y1 and Y0. Now we have 2 inputs, A1 and A0, and we have 2 NOT gates. So one NOT gate and the other NOT gate. And we have E for enable. And because enable is 1 for all of them, so let's just give enable. There we have the enable signal. And let's draw the input signal. So we have Y3 gets A1 and A0 directly without the NOTed form. So A1 and A0. Y2 gets A1 again. So it gets A1 and NOT of A0. So let it get the NOT of A0. Now Y1 gets NOT of A1. So we have the NOT of A1 and it gets A0 directly. So A0. Again in Y0 it gets the NOTed form of A1 and A0. So let's connect. This is A0 bar and we have A1 bar here. And that's it. This is our nice and shabby circuit diagram for our 2:4 decoder. Now let us see how to create a 3:8 decoder using a 2:4 decoder. So to understand how many number of 2:4 decoders we need, there is a formula. What it does is the higher order that we need to create this is called M2, and the lower order that we are using to create a higher order is called M1. Now the formula is to get the number of decoders that we need, it is M2 upon M1. So that is 8 divided by 4, which is 2. So we have 2. That means we need 2 2:4 decoders to create a 3:8 decoder. So that means we have 3:8 decoders. So we have 3 inputs and 8 outputs. So we have 2 2:4 decoder. So we have 1 and 2. Because there are 2:4 decoders, so that means we have 4 outputs for each of them and 2 inputs. Now these 2 inputs are going to be connected to each other. Here we have 1 and 2. And these are my 4 outputs. So we have Y7, Y6, Y5, Y4 for the first 2:4 decoder. And the next 4 outputs are Y3, Y2, Y1 and Y0. And my inputs are A0, A1. But this is 3:8 decoder. So that means we need to have 3 inputs. So the third input is A2, which is going to act as my enabler. But the other 2:4 decoder is going to get a NOTed form of my enabler. So this is going to give you the higher minterms, and these 4 inputs and outputs are going to give you the lower minterms. So this is how you create a 3:8 decoder using a 2:4 decoder. Now let us see how to create a 4:16 decoder using a 3:8 decoder. Again, let us calculate how many number of 3:8 decoders we will be needing. So 16 here is my M2, that is the higher level, and M1 is my 8. So the number of 3:8 decoder that we need is M2 divided by M1, which is 16 by 8, and that is 2. So we need 2 3:8 decoder to form a 4:16 decoder. So here we have one block and we have the other 3:8 decoder. Now because this is 3:8, that means we will have 8 outputs for each of them to make a total of 16. So here we have Y0, Y1, which goes to Y7 for the first one, and Y8 to Y15 for the other one. Now we have 4 inputs. So we have A0, A1, A2 and A3. So we have A0 connected to both of my 3-story decoder. A1 similarly connected to both of my decoders. A2 is again connected to both of them. And A3 is a special input. It is going to act as my enabler. So we have the enabled knotted form for the lower, and this goes here as the enabled form. Again, these are the higher minterms, and these outputs will produce a lower minterm. And there we have it. So we can create any decoder, any higher level decoder using a smaller level decoder, and we can use this particular formula to find out how many number of decoders are to be needed. In the next video, we will be covering what an encoder is, the different types of encoders, which is very important. And amongst those types, we will be discussing what a priority encoder is, and also what an octal to binary encoder is. The working of an encoder is just the opposite of the working of a decoder that we just discussed. Thank you for watching. Please like, share and subscribe to my channel. Till then, happy learning. See you next time.